Okay, a proof question, and what we're going to do here is prove that this is a multiple of 8. Now if you're not sure what to do with a proof, but you're given brackets, just expand. Just go with it. So we're going to expand 2n plus 1 squared and then 2n minus 1 squared. And then you're told that you need to take them away. And this is where we may go wrong. So tread carefully, my friends. Notice I've put it into brackets. Now as we take the minus through, it flips the sign of everything else. And now all I've got to do is tidy up. So when I tidy this up, you've got a 4n squared and I take 4n squared. So basically that's blur blur. You've got a 4n and another 4n. So let's combine those to give me 8n. And then you've got the 1 minus the 1 giving me nothing. So that's your answer, 8n. And the question was, show it's a multiple of 8. Well, if this is being multiplied by 8, so n is just any whole number. If it's being multiplied by 8, then it must automatically be a multiple of 8. So you've finished. Okay, let's go for a harder question, still a proof one. So what we're going to do is prove that the difference between the squares of consecutive numbers is equal to the sum of the two consecutive numbers. Now if they're consecutive numbers, one we might call n, and they're consecutive so they follow after each other, so the other one would be n plus 1. I'll remind you of the question again, that the difference between the squares of them. So we're going to square these and find the difference between them. Now as I said before, if you've got something in brackets with a square, then just expand the brackets. So that's going to n squared plus 2n plus 1. So the question was the difference between the squares of consecutive. So I've got to find the difference between these two. In other words, take them away from each other. So we'll do n squared plus 2n plus 1 minus n squared, which is going to give me 2n plus 1. And I had to prove that the difference is equal to the sum of the consecutive numbers. Yeah, the sum of these. Well, sum just means add. So when I add these together, I get 2n plus 1. And lo and behold, it's like some sort of miracle. You've proved they are the same.